The University of Washington Life Sciences building was completed in the fall of 2018. It is 207,000 square feet of office and lab space with a ground floor public cafe and a 20,000 square foot greenhouse. The building and plaza to its west function as a gateway to the university's main campus, connecting it to the South Campus and the local community. The building is located along the Burke-Gilman biking trail, which is a popular thoroughfare through the city. By providing a public plaza with bike racks right off the trail and a cafe with indoor and outdoor seating, the intent was to provide an amenity not only for the university, but also for the broader community. It's been wonderful to see the public having a picnic on the benches or plugging in a laptop to the deck, making themselves really feel at home. While there are active learning classrooms and conference rooms that can be used by anybody on the campus, the primary user is the biology department, with undergraduate teaching labs on level 1 and graduate research and office space on levels 2 through 5. One of the researchers' primary goals was to have high ceilings in their offices. To achieve this, we replaced the typical drop ceiling, which has ducted air for heating and cooling, and replaced that with radiant floors and chilled sails in the offices and chilled beams in the labs. By using this approach and exposing the chilled sails in the offices, we were able to raise those ceilings from 9'6" all the way up to 11 feet. In addition to operable windows in the offices and break rooms on the south and conference rooms on the north, the main stair was central to the natural ventilation strategy. Using both manually operated windows when in reach and automated operable windows when out of reach, the high volume of the stair facing west uses the passive strategy of stack effect to accelerate the airflow with additional fan assist when needed for a hybrid ventilation strategy. With a 32% water reduction, the water for the labs go through the reverse osmosis system, pumping the purified water to the labs and sending the reject water to the cistern where it gets filtered and used for irrigation in the greenhouses with a backup of city water if needed. One of the most impactful innovations on this project for reducing energy by 81% are the building integrated solar fins, which enabled the project to exceed the AIA 2030 challenge. The southwest facing facade, the researchers really wanted expansive views from their offices and driving daylight deep into their lab spaces, but we also needed to mitigate the solar heat gain. The solutions were these glass solar fins, which are integrated into the curtain wall system and can both block that low western sun from the west from hitting the window, and from the south side they're able to generate energy using a thin film solar technology, which is laminated into the glass fin. With over 80% energy reduction, electricity is generated both by the solar fins integrated into the southwest facade and the more typical rooftop solar panels feeding electricity to the grid. This was a first of its kind installation, and the design team worked closely with the UW Solar student group to realize this vision.
So UW Solar formed in 2012 out of students' interest in participating in the design and build of infrastructure on campus. There are several features of this project that are unique to our group and real milestones for our accomplishments. The solar fins really are they're kind of a landmark moment for us as UW Solar, but also as a campus in pushing forward to do something that's truly innovative on one of our facilities. The Life Sciences building was our first opportunity to get involved in a project as it was being designed and constructed. Students actually carrying out the complete preliminary design, carrying out fundraising, drafting and getting approval internally for the request for proposals for the vendor to do the installation.
Early on in the project, during the conceptual design phase, UW Solar was invited to participate in some of the sustainability charrettes, looking over the different initiatives that were possible in order to meet the building sustainability goals and the campus-wide sustainability goals. We were also invited to a number of site visits during the construction process, seeing exactly how things are put together, as well as some of the initial testing and commissioning of the systems. To fund the sustainable systems, UW Solar worked with the Campus Sustainability Fund to secure grants in the amounts of $120,000 for the water reclamation and reuse system, as well as an additional $300,000, which was the largest grant ever awarded by the committee for the solar and BIPV installations in the project. Actually being able to go over the construction site and see what goes on in industry versus what goes on in the classroom was an incredibly enriching experience.
As a professor in the College of Built Environments in urban design and planning, I think it's really important for us to have products like this, along with our typical scholarship, to give as examples of what's possible.
Having a year's worth of data is helping to understand the difference between our modeling and the actual building performance. For example, we had modeled the energy use intensity, or EUI, to be 152.7, and we're happy to see that it went down to 137. We also learned that combined energy generated between the solar fins and the rooftop solar increased by over 80,000 kilowatt hours per year. However, the water use intensity increased by 1.9 gallons per square foot per year, which is likely a sign that the cafe as well as the ground floor are getting more public use than originally anticipated. As a biology building, it was important to the users that the interior and the exterior of the building have a strong connection to nature. Using the principles of biophilia, the ground floor provides a choice of seating either next to the south-facing deck to soak up the sunshine, or on the other side tucked into the trees on the north side of the building. One of the biology professors and his wife donated 9 trees from their nearby property in the Onyx Peninsula as part of the forest sustainable management. We were fortunate to be able to walk the forest with them and their arborist to select the trees. These 200-foot tall Douglas fir trees were reassembled from base to the top over 6 floors on the elevator core. It seemed appropriate for a biology building to celebrate these magnificent trees at the heart of the building, as when ascends up the building, the bird chirps signaling the elevator stop change based on the species that would typically be found here in the Pacific Northwest at that exact level. While the rest of us just enjoy hearing the bird chirps and connection to nature, biologists get to have this additional insight. As students and faculty walk by the wood-clad elevators, we've heard that they feel compelled to touch the trees, that physical sensory connection to nature. Biophilia was a design driver for the exterior as well. To integrate with the tree-lined street of cedars on the north, a true wood veneer cladding was selected so that it felt nestled into the site. We learned from the users that biology is a synergy of nature and technology. So as one moves through a quiet tree-lined street, through the plaza toward the active Burke Gilman Trail, the building design then shifts to focus on technology with the metal, glass, and the high-tech solar fins.
It was incredibly rewarding to be able to work on this as a student, to see the hard work that I was putting in actively being constructed on campus, to be able to point to something and say, hey, I was a young student when I was able to work on this. This is like the crowning achievement of my collegiate career.